Welcome to myprojectbazaar.com.
Hello everyone. Now we're gonna see about building optimized web browser using cache services in cloud computing. An optimized web browser in cloud computing is an internet bot that systematically browses the World Wide Web, typically for the purpose of web indexing. We implement the proxy-based search engine using the cloud computing infrastructure. The request sent to server and the server send the request to metadata server. The optimized web browser searches the related content and sends it to the server. The server sends all the received data to the client. The large volume implies that the optimized web browser search can only download a limited number of web pages within a given time, so it needs to prioritize its downloads. The high rate of change implies that the page might have already been updated or even deleted. In cloud computing environment, cloud clients may view web pages stored in the cloud server storage. To support access to content even in offline mode, a content cache scheme in client device is proposed in this paper. In this scheme, content in the cache has its own content properties, and the content is classified into some categories divided by the content priority. In eviction algorithm on content usage, priority of classified content is assigned by user preference. Meanwhile, the user preference data is updated according to the content usage history. From repetition of this process, it is possible to manage the content cache reflecting client preference, which is changeable over time. Let me see the flow diagram for building optimized web browser using cache services in cloud computing. First, we start a process. Here we simulate a web browser in Java, where a user query is fetched from the user. The query, like Java or Oracle, something, a word, a phrase, is fetched from the user. Then the query is forwarded to the meta server. The meta server look for the query which is already present in a database or not, which is the cache memory is already available or not. Here, when every time the user is querying something, the count hit is calculated. When Java is accessed more than 10 times, means when a user give another time Java, then the count hit rate is get increased to 11. Then the query is look into cache server. First, it check for the cache memory. If if the data is already present, means no problem, or else it look for the cache memory. If we just give a cache memory 200 KB, then the storage is excluded from 200 KB, then it delete the old cache memory. Here the count rate is calculated. When user query is something like Java, the old query which is not accessible from any user, here the query is accessed only one time, then the unused file is deleted from the cache memory. Here cache memory is full, means delete the unused content and the new cache file is stored in the cache memory, or else it directly fetched from the cloud and the results is sent to the user. The user then get the web page and search results and the contents in each links. When the search result written 10 pages, mean the 10 pages, the 10 link contents is available to view from the users. Now the running procedure of optimized web service using cache services in cloud. First run the start.java, then click start and start the meta server here. Then start the cache server. The meta server will accept the request here and responds to the user query. Then cache server is started. Here requested. Now client request a query like Java. This is cloud location. Proceed. Cache size. This is a cache details. The query. After request, you get a result. This is search result. You can open the result in external browser also. Then the contents. Now these are the contents of each page. This is search content here for the Java. Now the script of the page. The search result page script. This is the HTML script here. Then result links. The links also separated from the web results. Now let me see the data which is present in the meta server. Just click metadata. Here this is a keyword. These are the meta server locations. Now cache details here. The file created date. Each file is created and the date is given here. Then frequency of access. Which keyword is says frequency? According to it, we delete the unwanted cache file from the cache server. Each file, each query, the date and time and frequency of access. If frequency of access is less, means we can delete from the cache memory. Deleted history. The keyword which is already deleted from the cache server is given here.